Hi, these are the data miners, and this is our project on predictive analytics for auto insurance claim. I'm Patrick.
Jacinta.
Cyril.
Nixon.
So we're going to talk about like table contents, predictive model of auto insurance claim. We're going to do the introduction, talk about the problem, the motivation and objectives behind the project, the related work, and of a brief overview, a data description of what is going on, a methodology, which is data preprocessing, feature engineering, model approaches. We're going to do experimental setup and evaluation, show the results, and do a discussion and key conclusion and findings. So also going to do limitation, show some future works in data and software. Yeah. So a brief overview of the problem. So the US insurance industry is a major economic sector. Auto insurance is a mandatory in most states. So the challenge is insurance companies need accurate risk assessment for fair premium settings. So in this project, we want to take the opportunity to do advanced data mining and machine learning to offer more precise prediction methods than traditional actuarial techniques. The end goal for this is actually to develop and evaluate a data mining pipeline to predict total auto insurance claim which is going to be 1, which shows that a person will take a claim, and 0 to show that the person will not take a claim. So for the model processing, it's going to be gradient boosting and XGBoost, which are top performing models for predicting auto insurance, and we're going to do other model processing. The key predictors will be advanced data mining techniques that can significantly improve prediction accuracy. On the performance insight, nonlinear model is essential for capturing the complexities in insurance data. And for price fairness, enhanced risk assessment contributes to more equitable pricing model. And we added future fraud detection. For detecting fraudulent claims is essential for effective financial management. So for the motivation, the motivating factor behind this project is predicting claim amounts, which will improve pricing and risk assessment.
Related works where the first one that we looked at was looking at the deep learning techniques that have significantly advanced predictive modeling in insurance. Also, we looked at how machine learning has been applied for claims reserving, enhancing the accuracy of predictions. Also, we looked at ensemble methods, which have shown effectiveness in fraud detection and improving detection rates. Another related work that we looked at was a comparative analysis of machine learning versus traditional methods for pricing and how this has been conducted and revealing the performance differences. Also, we looked at big data techniques that have been explored to leverage large data sets for better predictive modeling in auto insurance. Our data was sourced from the machine learning mastery public dataset that is publicly available. And the features that it had was that we had the driver demographics, the vehicle characteristics, and claim history. And also for the initial findings, we saw that there were several missing values in the credit score and annual mileage and an imbalance in the target variable. Data preprocessing, we performed data cleaning where we first identified the missing values in the key features. Then we dropped the records that had those missing values so that we could ensure the data integrity. And in outlier detection, we analyzed this using box plots and scatter plots. Some outliers were present, but nonlinear relationships were also noted. And in the feature scaling, we standardized numerical features due to varying ranges. In these graphs that show the model comparison, we saw the missing values that were in credit score and annual mileage, and they appear in that manner. Experimental setup and evaluation, where we used Python libraries like Pandas, NumPy, scikit-learn, XGBoost, LightGBM, Sharp, Matplotlib, and Seaborn. In the modeling approaches, we looked at linear regression because this model served as a foundational approach for estimating claims in the analysis. Also, we looked at polynomial regression as this technique is employed to effectively capture the nonlinear relationships present in the data. We also did ridge and lasso regression, and these methods were utilized to apply regularization, which helped to mitigate the risk of overfitting in the models. Also, we looked at gradient boosting, as this approach involved building models sequentially, enhancing performance through iterative improvement. For the feature engineering, the feature importance, we looked at the key factors like for influencing claims predictions, like the driver's age, the vehicle's age, annual mileage, credit score, and previous claims history, and both the driver characteristics and exposure factors were crucial. For categorical encoding, we did one-hot encoding for nominal variables like the vehicle type, and ordinal encoding for variables with a natural order. For the polynomial features, we created interaction terms and higher order terms to model nonlinearity, and this technique captures complex relationships in the data. And in dimensionality reduction, we evaluated feature importance to reduce dimensionality and enhance interpretability. And this process focused on the most impactful features.
Our results. On the table are our results, and you can see clearly that gradient boosting was the best among the various models that we tried out. It came out top with the lowest root mean square error of 0.234, followed closely by XGBoost, which had a RMSE of 0.251, and polynomial regression had an RMSE of 0.275. The baseline linear regression model had an RMSE of 0.339, which was much higher than the other models, which are better than it.
On the ensemble methods, gradient boosting and XGBoost effectively capture the complex patterns and manage outliers, right? The most influential factors, like we said, are the driver's age, the key predictors for the claims, are the driver's age, the vehicle age, the annual mileage, the credit score, and previous claims history. Our modeling approach include we did nonlinear modeling, which is crucial in addressing the various complexities that you find with insurance data. Future research should focus on predicting claim severity, particularly this is an insurance and we're trying to stay in business, and integrating telematics data. Conclusion and key finding. Ensemble methods, what we found is that ensemble methods like gradient boosting and XGBoost are the most accurate for predicting auto insurance claims.
Some of the limitations we faced were the data set size was smaller than typical industry standards. The study did not incorporate time series elements, and the focus was on claim occurrence, not the monetary amount of the claims. And lastly, the analysis did not include data on weather or the road conditions. And the future works that can be done will include predicting the claim severity to enhance model effectiveness. The data, our code and the data can be accessed on GitHub. There's a link we will provide in the notes. The dataset access, we obtain the dataset from auto insurance total claims, which is publicly available. Our documentation include data, Python script, Jupyter Notebook, and all the required files. Software requirements outlines the running of our code. Okay, thank you. That's all.